Welcome to the Prelab for Recrystallization. In this experiment, we will look at how to deal with the purification of solid compounds for the first time. We will also learn how to determine the melting point of these compounds. In this presentation, we will cover the Prelab Assignment, safety information, the goals of this experiment, and the methods that will be used to achieve those goals. Background information about recrystallization and how to purify a solid compound. Some specific information about conducting the experiment, how to clean up at the end of the experiment, and finally, some guidance on completing your post-lab analysis questions. Your pre-lab for this experiment consists of reading the assigned sections from the Techniques in Organic Chemistry, watching the demonstration videos on how to recrystallize and take a melting point, and preparing your notebook. Remember, this is an investigative format. If you note in the procedure, you'll be performing several small solubility tests, so you'll also want to prepare a table like the one found in your notebook. The safety information you need to know for this experiment is that the solids you will be working with are toxic and irritating. The solvents are also flammable and irritating, so you do not want to use them near open flames or any other source of heat. Prevent contact with your eyes, skin, and clothing by wearing gloves and aprons. And avoid inhaling the vapors, as well as ingesting any of the compounds. The goal of this experiment is to test the solubilities of 3 solutes in 5 different solvents. You will then take one of the solids and recrystallize it on a larger scale. To do this, the methods that we will use consist of testing approximately 100 milligrams each of transstilbene, 9-fluoronone, and benzoic acid in solvents with a wide range of polarities: hexane, toluene, acetone, ethanol, and water. You will fill in the constructed table you created to indicate whether each compound was soluble in the given solvent at both room temperature and when heat is applied. Once this is complete, you will show it to your instructor, who will assign you one of the compounds to recrystallize. You will then look at your data and decide which solvent or solvents works well at recrystallizing your compound. You will then measure out 200 milligrams of material, recrystallize it, and then take a melting point. Recrystallization is a purification technique. It allows us to remove impurities that may be present in a solid compound. The way we do this is by placing the solid in a flask and slowly adding hot solvent to the flask. The reason why we want to add hot solvent is that the solubility of a compound increases in a liquid when you increase the temperature. The goal is to make a hot saturated solution by using the smallest amount of solvent you can to dissolve all of the solid. Once a hot saturated solution is obtained, you then slowly cool the solution. As the solution cools, the solubility of the solid decreases, and you get a supersaturated solution. Eventually, the solid crashes out of solution as a precipitate. As it precipitates, the impurities remain dissolved in the solution and get filtered off. Let's look at a cartoon depiction of this process. Here I have a flask that contains a solid material at the bottom. You see that as the red triangles that represent the compound, and little tiny blue squares represent some small impurities. If I slowly add a hot solvent in which the solid is soluble in, eventually I will reach a point in which all of the solid is dissolved. At this point, you can see that both the red triangles and the blue square impurities are dissolved. In some instances, the impurities may be insoluble in the chosen solvent, in which case you would have to filter them off. For this experiment, we will not have to resort to this technique. At this point, you then simply cool down your saturated solution. And as the solubility of the compound decreases, the molecules align themselves with one another due to various intermolecular interactions and begin to form crystals. Note the impurities are still in solution because their concentration is very low in the first place. Also note that there is still some material dissolved in solution, the red triangles, because there is some solubility even at low temperatures. There are some key concepts to understand when thinking about recrystallization. The first is knowing how to choose a good solvent. This is one of the reasons we do solubility tests. In general, you want to choose a solvent in which your compound is not very soluble at low temperatures, but is very soluble at higher temperatures. For example, if I took acetaldehyde and wanted to recrystallize it, I can look up solubility data and see that it is somewhat soluble in ethanol. In fact, at 0 degrees, 18 grams of acetanilide will dissolve in 100 mils of ethanol. Notice, at 50 degrees, the solubility increases to 80 grams in the same volume. This means that if I dissolved 80 grams in 100 milliliters of water, or ethanol, at 50 degrees, and then cooled it down to 0 degrees, 62 grams would precipitate out. Another concept to keep in mind when recrystallizing is the adage that like dissolves like. So polar compounds will be more soluble in polar solvents like water, methanol, and ethanol. Make sure you think about the types of functional groups contained in your compound. If there are polar groups, it is a good idea to use polar solvents. Likewise, nonpolar compounds will be soluble in nonpolar solvents. The key is to find a solvent that is somewhat related in polarity, but not too related because then you run the risk of the compound being too soluble. The last concept you should think about is crystal size. You have to understand that the rate of cooling is going to affect the size of your crystals. The quicker the solution cools, the faster the crystal formation, resulting in smaller crystals. So the key is to cool your reaction slowly to obtain larger crystals and more pure samples. When conducting the experiment, take your time in studying the solubilities of the various compounds and solvents. Once you are given a particular compound to recrystallize on a large scale, you will want to select your solvent. You will weigh 200 milligrams of your sample into a 10 milliliter Erlenmeyer flask. You will then place your solvent in another small flask and heat it. Here we see the sample is resting on the bench and the solvent that is gently being heated. Remember, you don't want to crank up the hot plate, otherwise you will have a difficult time handling the glassware, and your solvents are going to evaporate too quickly. You then add the solvent slowly, once it is heated, to the sample flask in small portions until it dissolves. You then remove the solution from the heat and cool slowly to room temperature. At this point, you should start to see crystal formation. Once the solution is at room temperature, you can place it in an ice bath for 5 to 10 minutes to ensure complete crystallization. Once recrystallization is complete, you will take a stir bar and swirl the crystals around to make a slurry before you filter into a Hirsch funnel. Once all the crystals are transferred, you can then wash the crystals with cold solvent and allow to dry. To take a melting point, you need to ensure your sample is as dry as possible within the time frame allotted. If your crystals are large, you can crush them in a mortar to get a powder. You will then load a melting point capillary by pressing the open end of the capillary into your sample until there is 2 to 3 millimeters of sample in the capillary. At this point, you have to transfer your sample from the open end of the capillary to the closed end. You can do this by tapping the bottom of the capillary repeatedly until the sample migrates to the bottom. You will then place the capillary into the melting point apparatus and follow the instructions given on the front of the device. To clean up, you simply can wash any aqueous waste down the drain and place all the organic solids and solvents into the appropriate waste containers. In terms of data analysis, you want to make sure you discuss any structural differences between the solids and solvents when talking about polarity, and give reasons why you think the solvent you chose was a good choice.